This is AP Calculus 8-6, area between curves that intersect at more than 2 points. So we have talked about how to do the area between two curves when they only intersect at 2 places between A and B. But what happens if we have more than 2 intersection points? Like they don't just intersect at the 2 ends, but somewhere also in the middle. We have to understand how to account for that. If I were to do this, I would kind of treat it like 2 separate problems. If you notice, the red function is my f function and the blue function is the g function, and we want the area between the 2 curves from the intervals a to b. And notice the red function is on top from a to 0, and the blue function is on top from 0 to b. So what we're going to have to do is subtract those functions from each other, but we're going to have to account for where they intersect. A real simple setup for this would be to find the area between the curves from A to 0, and then find the area between the curves from 0 to B. As long as we know where these things are intersecting, and that's easy enough to find by graphing them, then we can set up 2 separate integrals to account for that entire area. So I could do this. I could do the integral from A to 0, and we know the integral from A to 0 would be the area between the curves in this portion of the graph. And I'm going to need the red function subtracting the blue function. So that would be f of x minus g of x dx. That would give me the area between the curves going from A to 0. And then if I want the area from 0 to b, I would add to that the integral from 0 to b of g of x minus f of x, the blue function minus the red function, dx. And this would give me the area between the 2 curves, accounting for both spots where they intersect. This one says find the area of the region between the graphs f of x equals 3x cubed minus x squared minus 10x and g of x equals 2x minus x squared. So the first thing I'm going to need to do is graph this and determine where the intersection points lie. So I have used Desmos to graph this one. And if you look at this, now this would be the cubic function, the red function, obviously, because it has to have 2 curves, 3 roots. The blue function would be the parabola, because it is facing down because the minus is in front of the x squared, and parabolas only have 1 curve, 2 roots. Now if you look at where these 2 things intersect, they intersect down here, and let me just draw this. They intersect right here, they intersect again right here, and they intersect again right here. So we would need to set up 2 integrals, this one minus this one. This one goes from -2 to 0, and this one would go from 0 to 2. So to set these integrals up, the left-hand portion would be the f of x function minus the g of x function going from -2 to 0, which is what we have right here. And then this portion of the graph, we would add to this area between 2 curves. So this portion would be going from 0 to 2, the integral from 0 to 2 of the g function, the blue function, g of x minus f of x dx. Now, notice in this one we're going to subtract f of x minus g of x, and in this one g of x minus f of x. So wouldn't those 2 things be opposites? For example, if I do 5 minus 2, I get 3, but if I do 2 minus 5, I get -3. So it's opposites, right? So if I subtract f of x minus g of x, that would give me what goes here, but the opposite of that would give me what goes right here. And so I could do this math pretty quickly, just do it once, and then the opposite would be what goes right here. So let's just do that. If I subtract 3x cubed minus x squared minus 10x minus 2x minus x squared, I would get, so f of x minus g of x would be 3x cubed minus 12x. Now if you think about that, 3x cubed, there were no like terms over here. Negative x squared minus negative x squared, well that just cancels out to 0. And then negative 10x minus 2x would be a negative 12x. So f of x minus g of x is 3x cubed minus 12x. And we need the integral from -2 to 0 for that portion. So then for g of x minus f of x, we need the opposite of this. So that would be 12x minus 3x cubed. And of course, if you're not sure about that, you could always take this and subtract and see what you end up with. Well, 2x minus negative 10x would be a 12x. And negative x squared minus negative x squared, again, cancels to 0. And then 0 minus 3x cubed gives us a negative 3x cubed. So they are, in fact, opposites. We have now set up this function. Another way, let's say you don't have a graph and it's really hard to tell where these things intersect. Remember, we can set these functions equal to each other to figure out the x values where they intersect. So if they're not whole numbers like these were, or integers like these were, you could find those decimals by setting these two functions equal to each other and telling where they intersect. So that's really not too much of a problem either to find your a and b functions. So at this point then I'm going to integrate. So for this one, when I integrate, I end up with 3x to the 4th over 4 minus 6x squared, going from negative 2 to 0. And then here I would have 6x squared minus 3x to the 4th over 4, going from 0 to 2. I would then plug in my values. If I plug in 0, I get 0. If I plug in negative 2, I get 12 minus 24. And then I'm going to add to that what I get when I plug these values in. When I plug in 2, I get 24 minus 12. And then I subtract from that what I get when I plug 0 in, which is 0. And then this would be a negative 12 plus 24, which is 12. And then 24 minus 12 is 12, leaving us with 24 as the area between the two curves.